Welcome to another JWT developer tutorial. In this guide, we'll walk you through integrating Apple's DeviceCheck into your Unity game for iOS. By the end, you will have a more secure gaming environment. Let's start with understanding DeviceCheck. DeviceCheck is a framework provided by Apple, specifically designed for securely identifying devices. It allows developers to generate and validate tokens associated with particular device, helping prevent fraudulent activity such as replay attacks. In general, DeviceCheck enhances iOS app security by providing a mechanism for device identification. In this tutorial, our primary objective is to fetch device token from the iOS device using iOS native code, manage this interaction between the Unity game engine and the native iOS code, and send the DeviceCheck token to a server for validation through Apple's DeviceCheck API endpoint. Based on this response, we will make informed decisions about how to proceed within our game. Now, let's delve into the implementation step by step. Let's start with the iOS native code. Our first step is to write Objective-C code to access these APIs, using the DC device class to interact with DeviceCheck functionalities. This code is responsible for fetching a token. It uses the DeviceCheck framework provided by Apple. The DC device class is used to access the current device, and the generate token with completion handler method is used to generate the token. If the iOS version is lower than 12, or if an error shows up during the token generation, an empty string is sent back to Unity. If the token is generated successfully, it encodes in base 64 and sent back to Unity using Unity send message. Then, we create a plugins folder inside Assets, and within this folder, we create an iOS folder. We save our Objective-C code inside this folder under the name unitybridge-helper.m. Now, let's understand how to integrate native iOS code within Unity for DeviceCheck token retrieval. We first create a C# script, name it for example DeviceCheck, which is responsible for managing the interaction with the native iOS code. Inside this script, we use the DLL importer internal attribute to indicate that the method fetchDeviceCheck token is implemented externally. The fetchDeviceCheck token method is called in the start method, serving as the entry point for fetching the DeviceCheck token. When fetchDeviceCheck token is called, it checks if the platform is iOS and not the Unity editor. If these conditions are met, it invokes the fetchDeviceCheck token method defined with the DLL importer internal attribute. Now, the token received from the native code is passed as parameter to the receiveDeviceCheck token method in C#. Within this method, the token is checked for validity. If it's not empty or null, then the sendToServer method is called with the token as parameter. Within the sendToServer method, we call this method on the DeviceCheck microservice. First, ensure you have already added Bmumble to your Unity project. Create DeviceCheck microservice and ensure it functions correctly. Now, the receiveDeviceCheck token method in the C# code is invoked from the native Objective-C code using this line. Unity send message is a Unity provided function that allows you to send message from a native code to Unity scripts. It takes 3 parameters. The name of the game object in Unity to which the message should be sent. The name of the method to invoke on that game object, in this case, is called receiveDeviceCheck token. The message or data you want to send, in this case, is the DeviceCheck token converted to a C string, token string. Then in Unity, we make sure we create a game object named DeviceCheck token listener and attach the script to it. Next, we will focus on implementing the logic to send DeviceCheck token for validation. First, retrieve necessary configurations like private key content, team ID, and key ID from Bmumble configurations. To configure these data inside Bmumble, we need to first obtain them from the Apple developer account. Go to the Apple developer account, then click on the account. Navigate to the Certificates ID Profile section, click on Keys, then click on the plus button, and write the name of the key, for example, DeviceCheck. Enable DeviceCheck, click on Continue, then Register. Now, download the key. Open the downloaded file and copy its content. Make sure to remove the begin private key and the end private key lines, and only copy the inner content. Go to the Bmumble dashboard, then navigate to Operate and select Config. In the Accounts section, click on the Edit button, then the plus button, and enter private key PEM as a key and paste the copied data. Go back to the Apple developer account, copy the key ID and add it to Beamable as well, entering key ID as a key. Regarding the team ID from Apple, go back to the Apple developer account, click on Membership Details and copy the team ID. Paste it inside Beamable also, entering team ID Apple as a key. Remember, you can choose whatever name you want as a key inside Beamable, but ensure to use the same key ID when calling them in the code. After retrieving these configurations from Beamable, ensure they are not null to avoid problems in the rest of the code. Then, generate JWT token using the provided private key file content, team ID, and key ID. Inside the generate JWT method, we use the elliptic curve digital signature algorithm for signing. Create a new instance of the ECDSA class. Import a private key into this referenced object. The private key is provided as a base64 string. In this case, is our private key PEM content, and is converted to its binary representation before being imported. Create an instance of signing credentials, which represents the credentials used for signing a token. Create a new instance of the JWT header, which represents the header of the JWT, and we add a key ID, key identifier, to the header. The key ID is provided as parameter to the method. Create a new instance of the JWT payload, which represents the payload of the JWT. It contains claims such as issued at, expiration time, and issuer. Ensure that the issued at and the expiration time are expressed in seconds when converted to Unix timestamps, or you will get an error later. Also, add team ID to this issuer. Create a JWT token object with the specified header and payload. Initialize a JWT token handler for generating and handling JWT tokens. Generate the JWT token string using the provided token handler and return it. To generate the JWT, we need to import specific libraries. In .NET applications, including Unity projects, the namespace to use for JWT-related functionality is Microsoft Identity Model Tokens JWT. This namespace contains classes and types related to JSON Web Tokens within this package. There are two methods to import this library into Unity. The first method is to add NuGet to Unity by uploading the NuGet Unity package. Then, click on NuGet, manage NuGet packages, and search for Microsoft Identity Model Tokens JWT. Click on Install, and it will automatically install the necessary packages to allow us to create JSON Web Tokens using the private key PEM. The second method is to go to the NuGet Package Manager website, search for Microsoft Identity Models Tokens JWT, click on the first link, then click on Download Package. After downloading the file, change its extension from this to .zip, then unzip it. Navigate to the lib folder and copy all the appropriate DLL file inside Unity, specifically inside the package folder. Make sure to add all these packages to the Unity the same way we added Microsoft Identity Model Token JWT. Then do reimport all inside Unity. Afterward, ensure to add the name of these DLLs inside the Beamable microservice as shown in this file for both methods. Now, let's go back to the send to server method. After generating the JWT token, we prepare a payload for the DeviceCheck API, including device token, transaction ID, and time span. It's crucial to ensure that transaction ID and time span are in milliseconds when converting to Unix time span to avoid errors later. Then, we perform an HTTP request to the Apple's DeviceCheck API. We set the authorization header using the generated JWT token. Next, we serialize the payload to JSON. We make a POST request to the Apple's DeviceCheck API. Then, we read and log the response data. The result of the operation, success or failure, is returned to Unity and shown in the check device text. Now, ensure to build the microservice and click Run to verify that it functions correctly. Then, build the project and open it using Xcode. Make sure to add the DeviceCheck framework to your Xcode project. You can do this by navigating to Unity Framework Targets, expanding link binary with libraries, then clicking the plus button and adding DeviceCheck framework. Similarly, follow the same steps for adding the GameKit framework. Finally, click on Run to test the app on your iPhone device. Regarding the response, if Apple server responds with the 200 static code, it indicates that the token is valid and has been successfully verified by the DeviceCheck API. This means that the device associated with the provided token is recognized as genuine by Apple's system, enhancing the security of your application interactions with the device. Thank you for watching. I hope you enjoyed this and found it useful.